All right, we're going to start off here with rational expressions. And so the first thing we're going to look at is domain. So for the question of domain, there's really only two things we need to worry about right now. So there's kind of two rules we need to just memorize. So the first one here says that because it is impossible to divide by 0, rational expressions can have domain restrictions. To find them, set the denominator not equal to 0. So anytime we see a denominator, it should be not equal to 0. And then the other one is anytime we have a square root, we need to set the inside of the square root greater than or equal to 0. Because remember, if we have a negative inside a square root, it leads to imaginary numbers. Okay, so for the first one here, if it's our question here is find the domain, those are the only two things we care about. Just denominators cannot equal 0, and then the inside of the radical is greater than or equal to 0. So on a question like number 1, where we don't have a denominator and we don't have a radical, whenever you don't have those two things, then it's just going to be all real numbers. It's just kind of saying that there are no restrictions. Those are the only two types of restrictions we're going over right now. There is one more later on having to do with logarithms. We'll go over that later. But if you don't have any of those, then it's going to be all real numbers. Sometimes they draw that with like the fancy R with the extra line in it. That does mean the same thing. Okay, number 2 though, so once again, question is domain here. Number 2, I would say, does have a domain restriction because the denominator here, we can see we do have a denominator, so we need to say the denominator cannot equal 0. And so in this case, I would actually factor that. So to factor this one, I would think of two numbers that multiply to 6 and add to -5, because that's a times c on top and b on bottom. So that sounds like -3 and -2 to me. Since we have no number in front of the x squared, we can go ahead and do the shortcut here. So we can say x minus 3, x minus 2 cannot equal 0. And that means that each of these individually cannot equal 0. And so if I add the 3 over, this one would say x cannot equal 3, and this one would say x cannot equal 2 if I add the 2 over. So those would be my two restricted values on this one. They are what make the denominator 0. You'll notice I didn't really do anything with that x up top. It's not that it's irrelevant overall, it's just that it's irrelevant to the question of domain. For domain, we only care about radicals or denominators. So since that x up top is not in a radical, it's not in a denominator, it's not important to this question. All right, last one here, you can see we actually have a radical and a denominator, so I can apply both rules here. So we said the denominator cannot equal 0, and then the inside of the radical must be greater than or equal to 0. So I'm going to actually do both. So this time I do care about the numerator just because it is in a radical. So now I need to solve each of these individually. So this one would say if I added the 5 over, x cannot equal 5. And then the next one over here, we can add the 1, so that would be 2x is greater than or equal to 1, and then divide by 2, and that would say x is greater than or equal to 1/2. So that one is coming from the radical, that one is coming from the denominator. Okay, scrolling down here, next up we have multiplying fractions. So for multiplying fractions here, the big thing on multiplying and dividing fractions, we cannot, we do not need common denominator to multiply fractions. So that's what we got going on here on number 4. I don't need to worry about common denominator. I really should just factor everything and see what can cancel. So if I factor the top left here, thinking of two numbers that multiply to -3 and add to +2, that would be +3 and -1. Nothing in front of the x squared there, so I can just do the shortcut and call this x plus 3 times x minus 1. And then on bottom here, I need to think of two numbers that multiply to 16 and add to 8, so that would be 4 and 4. Once again, nothing in front of the x squared, so I can just use the shortcut there and say x plus 4, x plus 4. Top right here, I wouldn't do the x factoring because it's just a binomial. I do see I can take a 3 out front, so I would just go ahead and do that, factor out a 3. And on bottom, I also see a GCF there. I can take an x out front. It's actually not difference of perfect squares because the x is not a perfect square. So I'm just going to GCF an x, and it'll leave me with x minus 1. Now, these actually also ask us to state the domain, and so I'm actually going to go ahead and state the domain right now. So for the domain, remember, like we talked about up top, it would just be any x value that makes the denominator 0. So these x plus 4s on the bottom, I would say for my domain, on number 4, that is telling us that x cannot equal -4. If you kind of think about it there, a -4 would turn that parentheses into 0. For the x right here, that's GCF'd out front, that would mean that x cannot equal 0 because 0 would make that 0. And then for x minus 1, we would say x cannot equal 1. Okay, so that would be my domain, and now I can actually start canceling stuff out, so I can cancel this and this, right? And so you can actually see the x minus 1 gets canceled out, but I still need to say over here x cannot equal 1. That kind of carries over even after you cancel stuff out. That's why I did the domain before I started canceling. I also see we can cross out an x plus 4 there, and so what we have left, I don't see anything else, so what we have left over here is 3 times x plus 3 up top. And then what's left over on bottom is x times x plus 4. Now this is a good answer. I have a slight preference here to distribute that 3 in the numerator. I like the numerator in simplified form with no parentheses. However, the denominator we can actually keep in parentheses. So I'd say both of these are right. The second one I like a little bit better. Is actually division. Now the only rule for division is really the same as multiplication. It's just multiplying by the reciprocal. So we can always switch this into multiplication, and then we have to switch or flip to the reciprocal of this second fraction back here. So the first fraction is going to stay the same. Okay, so there we go. Okay, now kind of the same as the last one, number 4. We need to just factor everything and then see what we can cancel out once we factor. I'm going to actually start on the top right. This top left one's the kind of special one, so I'm going to get to it in a minute. So on the top right there, we would think of two numbers that multiply to 6 and add to 5. So I would think that would be 5. Wait a minute. Multiply to 6 and add to 5. Oh, not 5 and 1. No, it's kind of the other way around. It would be 2 and 3, right? Multiplying to 6, yes, and 2 plus 3 is 5. Once again, nothing in front of that x squared, so I can use the shortcut and just say x plus 2, x plus 3. And then on bottom right here, thinking of two numbers that multiply to -4 and add to -3. So that sounds like -4 and +1. So we get x minus 4 and x plus 1, once again using the shortcut there. Now, x to the third plus 8 over here, that is a special perfect cubes factoring. So perfect cubes factoring is always one binomial and one trinomial. You do the cube root, so that cube root of x cubed would be x, the cube root of 8 would be 2. And then I fill out the second parentheses with the first, so first times first, x times x is x squared. First times second over here, x times 2 would be 2x, and then last times last, 2 times 2 would be 4. And then for the pluses and minuses, we use SOAP. So since this one was a plus, we got same, opposite, and always positive. And then on top here, I have 4 minus x. Now I'm kind of anticipating down here, I have x minus 4. And obviously 4 minus x is not the same as x minus 4. But what we can do in these cases, when the signs are switched, sometimes we can take out a -1 in front. And that'll switch this to -4 plus x, because taking the -1 out front, we'll just switch the signs inside, and so now the 4 will flip to negative and the -x will switch to positive. All right, so then next up, we can start crossing stuff off here. So I know x plus 2 can cross off with x plus 2, and then x minus 4 actually can cross off with -4 plus x, because you can see the 4 is negative and the x is positive, so although the order is different, they are the same. I don't see anything else I can do here, so I would just leave my denominator as x squared minus 2x plus 4, and then x plus 1, okay. And then my numerator, I have -1 parentheses x plus 3. Now, if I'm going to stick along with my advice on the last one, I would actually distribute that negative in there. So kind of a little bit better way to write this would be negative x minus 3 on top. I would always, though, leave that denominator in the factored form. Well, that's not 24. It would be 2x plus 4 times x plus 1. Okay, perfect. Either one's okay, but slight preference to the no parentheses in the numerator, the simplified form. All right, let's move along here. We'll go down and do number 6. Now, number 6 and 7 here, we have adding and subtracting. So for these ones, what we really have to think about is the common denominator. So we can only add or subtract fractions when we have common denominators. So these denominators do not look common, but if I factor this one, they may have more in common than we think. So I'm going to factor on number 6 here, thinking of two numbers multiply to -2 and add to -1. So that'd be -3 and 2. So I can really think of this one as x minus 3 and x plus 2. So when I think of it like that, I see that they actually do have some stuff in common. So you just have to multiply by what they're missing. So the first fraction actually isn't missing anything. It has everything. This one's missing an x minus 3. So I need to multiply that technically top and bottom. And then this one's multiplying by x plus 2 on top and bottom. So I'm making these all now together in one fraction here. Actually, let me use a different color for this. Kind of show it's my next step. So I'm combining this all into one fraction. The common denominator is going to stay the same, x plus 2 times x minus 3 in whatever order you want. Order doesn't matter there. And then my numerator, I'm going to get kind of from the top here. So first of all, this one we didn't multiply by anything, so we just have x. Now this one, we need to take this -2, and you got to be careful when you have a negative like that, it's got to go with it, and we're going to distribute it into that parentheses. So that's going to become -2x plus 6. Okay, so then next up, this one's actually the most challenging one. I actually need to think of this x minus 1 here as being in parentheses. And so if I'm thinking of it like that, I have two parentheses multiplying by here. I have to FOIL them. I have to multiply everything from here by everything from here. I also have a negative in front here. Now I could distribute the negative into this one first and then FOIL. What I always think is better, I like to do a negative and then do my FOIL here and then distribute the negative into it. So my FOIL would be like first times first is x squared. Okay, outer times outer is plus 2x. Inner times inner is minus 1x. And then last times last is minus 2. Okay, so now I can distribute that negative into there. I could combine the like terms in there first. I'm just going to go ahead and distribute this negative and just put it down here. So that'll become -x squared minus 2x plus x and then plus 2. So I didn't really worry about combining the like terms because that's going to be my next step, like all on the numerator here. So I didn't really need to do it there. And again, we have to FOIL anytime we got two parentheses multiplying by each other. And then if it's a minus here, just like we saw here, we're going to have to at some point distribute that negative. Okay, so we're ready to write our final answer here. We're going to keep our denominator in that factored form. And then in the numerator here, we are going to combine like terms. Now I see -x squared does not have a like term, so I'm just going to put that there. For the x's, I got plus 1x, and then minus 2x is going to make -1x, and then minus 2 again will make -3x, and then plus 1x is going to make -2x. So I'm getting -2x there. Let me double check that. So the other way you can think about it, let's see, the two positive x's combine and cancel out with one of the -2x's, and there's a -2x left over. Yeah, I think that's right. Okay, and then lastly, our numbers, we got a plus 6 and a plus 2, so that's going to give me plus 8. I'm just going to box that up right now. I could look at factoring that numerator, but remember we kind of like the numerator in the simplified form anyway. Oh, and I should state the domain here. So our domain would be, I would say, x cannot equal -2, because you can see -2 makes that parentheses 0 in the denominator, cannot have 0 in the denominator, and so also 3. All right, number 7, gonna be kind of similar here. So for this one, again, we're gonna factor. We do need to factor that 2x squared plus 5x minus 12. So let me give myself a little more space here. We'll erase some more. Okay. All right, so for this one, we'll think of two numbers that can multiply to -24 and add to 5. Remember, we have to do a times c up top, so that's like the 2x squared and the -12. It's really the 2 and the -12. So I think that would be, what would that be? What multiplies to make 24? We got 1 times 24, 2 times 12, 3 times 8. Ah, there it is, 3 and 8. So we'll do +8 and -3. Okay, now this one we should use the grouping technique. So we use that 8 and -3. Anytime there's a number out front like the 2 here, we cannot just say x plus 8, x minus 3. It's not going to work. So we got to rewrite this 2x squared. We split up this middle term, which would be plus 8x and minus 3x. And then we do the minus 12 out there. And then we group them up in groups of 2. And then what can we take out of the first group is a 2x, leaving us with x plus 4. And then we take out a -3, leaving me with x plus 4. So we get 2x minus 3 times x plus 4. Okay, so that is our denominator there. So I should kind of rewrite this whole thing. So we got x over 2x minus 3 plus 5 over, and I'm going to rewrite that denominator in the factored form. And then minus 3 over x plus 4. Okay, and then once again, we just have to multiply by what they're missing. All right, so this first one you can see is missing the x plus 4, so we got to multiply that on top and bottom. This last one is missing the 2x minus 3, top and bottom. Okay, and the middle one's not missing anything. It has everything we need. So then we'll make this all into one big happy fraction, the common denominator, 2x minus 3 and x plus 4. And then in the numerator, I'm going to distribute in here, so that's going to be x squared plus 4x. This one is just 5, nothing to distribute there. We didn't really multiply. And this one I need to distribute a -3. So it's going to be -6x plus 9. And then lastly, we'll just combine like terms in that numerator for our final answer, which is going to be, let's see, what do we got? X squared. And then we have 4x and -6x, so that's -2x. And then plus 5 and plus 9 makes plus 14. And then the bottom will still just be that 2x minus 3, x plus 4. So that would be my answer here. Now for domain, you can see in the denominator, I think pretty clearly, x cannot equal -4. The other one may not be quite as clear, so you can say 2x minus 3 cannot equal 0. We would add the 3 over, so 2x cannot equal 3, and then divide the 2. So I would say x cannot equal 3 over 2 for my domain. All right, next up we got number 8. So this is what we call a compound fraction, kind of a fraction within a fraction. With these ones, I like to just kind of separate the overall numerator and denominator. And so make them into one simplified fraction over one simplified fraction. Now the bottom I would say is already one simplified fraction, but up here I need to do this subtraction, which means I got to get a common denominator, so I should multiply this one by x plus 1. Again, kind of multiply by what they're missing. We're going to multiply this one by x minus 1. So now we can make this all together under that x plus 1, x minus 1 common denominator. The numerator, I'll go ahead and distribute that 1, which will just be x minus 1. And then I'll distribute a -1, which would be -x minus 1. If I combine like terms there, it's going to be, let's see, x minus x will cancel, and then -1 and -1 make -2. And then down here we got x plus 1 times x minus 1. Now, so that's kind of done in the numerator. So now I'm going to bring this denominator back over. So the 2x over x minus 1 squared. And then since this is really division, this middle bar, remember that division means multiply by the reciprocal. And so I like to show that using this little I call it a little pigtail notation here, kind of just reminding me as you bring that up, flip it upside down, and it can become multiplication, because remember, like division can flip and become multiplication. So it'll look like that. Okay, so now I can actually start canceling stuff out here. Now I can actually cancel out this x minus 1 on bottom. I can cancel out, I see it as canceling out with the squared on top. If you want to kind of think of the squared, it's just like x minus 1 times another x minus 1. It's like this one got canceled out, so there's still one x minus 1 left. All right, I cannot cancel out x minus 1 with x plus 1. They're not the same. But I can cancel out this 2 with this 2 because they are just multiplying other stuff. Now, when I do that, the negative is still left over. So what I'd probably do is cross it off and put like a -1 there to remind me that -1 is still there. If you think about it, like -2 divided by 2 is -1, right? So it's just that -1 is still there as the x is still down here. Okay, and so now what is kind of left over here, this one's kind of gone because I flipped that upside down. But what's left over, on top I have a -1 and I have x minus 1. On bottom I have an x from right here and then the x plus 1 from the other side over here. Okay, and I would probably write that as, I would probably distribute that numerator, distribute that -1, but remember I don't like that denominator distributed. So I'd leave it like that. All right, next up, number 9. So for this one, again, I would do the subtraction in the numerator. So I would multiply this one by a plus h to get that common denominator. Multiply this one by a. All right, and so now my denominator here, I got a times a plus h. The numerator, I need to actually multiply here, so 1 times a is a, and over here I need to distribute this -1, so I get minus a minus h. All right, combine like terms, we get a times a plus h. On bottom still, combine like terms, the a's cancel out, and I get -h. All right, and now I'm going to bring this h from way over here. Now that does go on bottom, but I'm going to write it as h over 1. Which is just going to remind me that I need to flip this upside down and turn it into multiplication, just like we did last problem. I can cancel out the h here. This is gone because I flipped it upside down. So it looks like up top I'm just left with -1, and on bottom I'm left with a times a plus h. All right, next up, number 10. Now, a lot of people would want to send this negative exponent down to the bottom, send this negative exponent up to the top. Because it's got other stuff adding and subtracting to it, like these minuses, we cannot do that. What you can do is kind of drop them into their own little mini fractions. I'll kind of show you what I mean here. So I can call this one 2 over x. Because remember that -1 exponent does not apply to the 2, just the x. So I'm going to drop it down to a little mini fraction. So down here I can do 4 over x squared. And then I would put minus 81 over 1 here to make that just a fraction. And then 9 over 1 right here. Okay, so now I need to do common denominator in the numerator. So I'm going to say that means we should multiply this by x. And that's going to become 9x minus 2 over x. And then I'm going to kind of do the same thing down here. This one's got to multiply by x squared. And so that's going to become 4 minus 81 x squared over x squared. Okay. So now we can go ahead and multiply by the reciprocal. So this one can be times x squared over, And actually, I notice on this one, it's actually the difference of two perfect squares. So as I'm flipping it upside down, I'm going to factor it. Now it's kind of backwards from difference of perfect squares, how it usually looks, but that's all right. I can still do it. So the 4 is going to turn into a 2 and a 2. We always, on these ones, have 1 plus and 1 minus, and then the 81x squared is going to turn into 9x. Now, this is gone. We kind of flipped it upside down already. So now we can start canceling stuff out. Now the x squared and the x kind of can cancel out, but it's partially because that x squared can just turn into x up there. Now 9x minus 2 is not quite the same as 2 minus 9x. But what I can do here, if I kind of come down here as my next step, I can take out a negative 1 in front of that and call it negative 9x plus 2. I'm going to go ahead and multiply it by the x that's left over there. And then down here, our x is gone over here, but we do have 2 plus 9x and 2 minus 9x. Now you can see that when I take that negative 1 out of this 9x minus 2 and switch it, it does match up with this 2 minus 9x on bottom. And so I can cancel those out and get my final answer here, which will be negative x over 2 plus 9x. Negative x, I just did the negative 1 times x. All right. Let's move on to number 11 now. So this number 11, I would use a u substitution technique. I would let u equal 1 plus x squared. We can do that anytime we have like a kind of something that's showing up multiple times, especially if it's in parentheses. And then we can rewrite this then as u to the 1/2 power minus x squared times u to the negative 1/2 power. And then actually I can write the bottom as u as well. So every time I saw that 1 plus x squared, just replace it with a u. Now once again, I cannot move this negative exponent down to the bottom right now because we have this subtraction. So I need to factor it out to the front and then I can move it down. So when I factor that u to the negative 1/2 out front, the u actually is going to increase. Remember when you GCF a negative exponent, your exponents increase. When you GCF a positive exponent, they decrease, but this time we GCF a negative exponent. So it was 1/2, I took out 1/2, so it's going to increase by 1/2, so it's just going to become 1 whole u. The other way you can do it, you can do what you had minus what you took out. So we had 1/2 power, we took out a negative 1/2 power, so that's going to be 2 over 2, which is just 1. So that means it's u to the first power. And then over here on this second term, I have the x squared left over, and then I took that u to the negative 1/2 out, so that's gone. So it should be looking like that. Now, what I can actually do next is, now that this u to the negative 1/2 is GCF'd out front, I can move it to the bottom and make it a u to the positive 1/2. And then I would actually rewrite this u that's already down here, since it's the first power, I would write it as the 2 over 2 power. So that in my next step, I could add those exponents and call it the 3 over 2 power. Now in the numerator, I just have this u minus x squared left over. I would actually plug back in my u. So I would call that 1 plus x squared plus x squared. So I just replaced u with 1 plus x squared. I didn't need the parentheses anymore, and so I'm actually going to now replace the u on bottom with that as well. And then combine like terms in the numerator. It looks like it's going to be 2x squared plus 1. Oh no, I'm noticing I made a mistake. I'm going to back up now since I caught it. So actually this was supposed to be a minus right there. So since that was a minus, those cancel out, and I'm actually just left with 1 in the numerator, and so I don't really need that plus there. So actually that would be my answer because the x squared's canceled out. All right, next up, let's do number 12. So this one I would use that u substitution again. I would let u equal x plus 6. So we get 2x u to the 4th minus, I would rewrite that as 4x squared u to the 3rd over u to the 8th. Now I cannot subtract the exponents yet again until I GCF something out front. So I'm going to go ahead and do that here. So I would, actually, you can GCF a 2x u to the third, can't you? So that both of them can divide by a 2, both of them have an x, both of them have u to the third. That will leave you with what? U minus 2x. We've got u to the 8th on bottom. Okay, now we can actually subtract these exponents. I call it like the battle. So with these 3u troops fight these 8u troops, all of these 3 die, and then some of these die, but there's 5 left over. Just get that by subtracting, and they are on bottom. And now I think I can plug back in, so I get 2x, and then inside of here, I'm going to plug back in that x plus 6 for u minus 2x. And on bottom, we have x plus 6 to the 5th power, plugging that u back in as well. Combine like terms in that numerator. I'll do this in a new color since it's a new step. Okay, so we got 2x times x minus 2x is negative x plus 6. And you can see that's not going to cancel out with the x plus 6 on to the 5th power on bottom. So that's good. But once again, that slight preference, if you distribute that 2x into the parentheses, that would be negative 2x squared plus 12x. Keep that denominator just like that.